Hello, Integrated Math 3. So today we're talking about the sum of arithmetic sequences and the sum of geometric sequences. Let's talk about the sum of arithmetic sequences first. So in your assignment document, for those who are doing the asynchronous work in the morning, you're going to be looking at the sequence of the distance per second that this skydiver fell that we were looking at last week. And that sequence starts 16, then we add 32 and get 48, then add 32 and get 80, then add 32 and get 112, and we keep adding 32 all the way up here until 272. And the question we want to ask ourselves today is, what is the sequence, what is the sum of all of these numbers? So let's take a look at a simpler geometric sequence to answer that question. Let's say we have a sequence S sub n equals 1 plus 2 plus, let's do 1 plus 3 plus 5 plus 7 plus 9. If we wanted to know the sum of the sequence, now this is a basic sequence, we could probably do it in our head, but what if it was a sequence that had 100 terms in it, and we couldn't do it on our head, or it'd take a long time to do in a calculator? Well, we're going to develop a strategy. I'm going to show you right now what that strategy is. Let's write this sequence backwards. So instead of 1, 3, 5, 7, 9, let's write 9 plus 7 plus 5 plus 3 plus 1. So we have the same exact sequence, it's just written backwards. And I wrote them right on top of each other. What if we added these two sequences together? So that they're the same exact sequence, what if we added this sequence to itself, the forward version and the backward version? We would get 2 times S sub n equals 10 plus 10 plus 10 plus 10 plus 10. 1 plus 9 is 10, 3 plus 7 is 10, 5 plus 5 is 10. All of these sums, all of these numbers add together to 10. And we can see that because in our forward sequence, where we're going 1, 3, 5, 7, 9, we're adding 2 each time. Add 2, add 2, add 2, add 2. And when we write the sequence backwards, we're doing the opposite. Subtract 2, subtract 2, subtract 2, subtract 2. So when we go from 1 and 9 to 3 and 7, we've added 2 and subtracted 2. So our sum is the same every time. So now we have 2 times S sub n equals 10 plus itself 5 times, which is 50. So if 2 times S sub n is 50, we can divide both sides by 2, and we get the sum of this arithmetic sequence is 25. So if we added up 1 plus 3 plus 5 plus 7 plus 9, we get 25. So we're going to follow the same strategy to find the sum of any arithmetic sequence. And when you look at assignment 321, this sequence, 16, 48, 80, 112, it's reflected right here. It's shown right here in the document. And then that sequence is also shown backwards. So you're going to do the same exact thing. We're basically adding the sequence to itself, but we're adding it in the forward and backwards direction. And we're going to end up with a pattern that's very similar to what we see here on this Jamboard. And it's going to let us determine the sum of any arithmetic sequence. Bye-bye.